Okay, I'm going to go over 3 problems from Chapter 4 that I've got a lot of emails about. They're going to be similar to number 96 and 98 and then 108. So the first two require a little bit of math, and I think that's why people are getting a little confused. So this one's similar to 96 that we're looking at right now. It says pretend element, a hypothetical element, has 3 isotopes. And these are their natural abundances, 5%, 65%, and 30%. They also give you the mass of each one. The first one weighs 299 AMU, second one 300 AMU, and then the last one 301.0 AMU. And then they want me to calculate the average mass, so the atomic mass. So we only use one equation when we're doing atomic mass. It is, oops, sorry about that. It is mass equals the mass of the first isotope, let's write 1 there, times the abundance. Now this is where you can get into a little trouble. Remember, the abundance has to be as a decimal number, not a percent. And to that, we're going to be adding the mass of isotope 2 times its abundance. Again, don't use the percent. Use it, make it into a decimal number, plus the mass. In this case, we're going to be doing it 3 times, right, because there's 3 isotopes. So plus the mass of the third isotope times its abundance. So, if there's 4 isotopes, we'd be doing this yet again, and you just add all the results together to get your grand total. Alright, so again, the masses are given to us. So that's this 300, this 301, and the 299. So I'm going to go ahead and put those in. And again, in the interest of space, I'm going to leave off the units. But when you do this, you should be writing in the units. That's one of the things that we got to get good habits on, is writing out all our units. Alright, so it's 299.0. And then the second one is 300.0. And then the third one is 301.0. Alright, now the second number here, of course, is these abundances. But again, we got to take those numbers, which you see as percents here, and we gotta turn them into a decimal number. So the way you do that is you divide by 100, or if you want in your head, you can just move the decimal place. We'll be moving it over twice for each one of these. So the only tricky one is this 5% one, right? Because if you move it over twice, you kind of have to kind of add a 0 there. You'll be making it like 0.05. So let me go ahead and put those in, and we'll see what we come up with. So the first isotope is 5%, in other words 0.05. Second one is 65%, so again 0.65. And then the last one here would be 30%, which of course is 0.300, moving that decimal over twice. Alright, so I'm going to go ahead and type it all in and come up with my answer. So let me go ahead and I'm going to grab out my calculator here, and I got to work it out. So it's 299 times 0.05, and then we'll be adding to it, so plus 300 times 0.65 plus 301 times 0.3. And we get an answer of 300. Now I got to worry about sig figs. We're never going to forget about sig figs here. So I'm looking at all these numbers I see up here. I see 5%, I see 65%, see all these other numbers. And if I keep looking at them, most of them have 4 sig figs. Remember, these trailing zeros count. The only one that doesn't is this 5%. This 5% only has 3. So we're going to have to round our answer to 3 sig figs. Trailing zeros count, so we got 3 in that 5% number. We got 3 sig figs. Alright, so I'm going to round my final answer to actually just 300. We got to be a little careful actually though. 300, that actually only has 1 sig fig. So a couple tricks you can use here. You can either just put a dot at the end, which would make these trailing zeros with a decimal. Oh, a little tricky there. And then this would have 3 sig figs, or if you want, another way of doing that would be to put that answer in scientific notation. Either case, the other thing I want you guys to always do besides rounding is to always put units. So on that answer, the units should be, just like when you look up at the masses they gave us, they should be in AMU. So we're going to write that down as our unit. Again, show the equation you're using, show your answer, round it correctly with units. So we got to get in all those good habits. All right, so I hope that helps you out with 96. Now let's go ahead and move on to the next one, which is, we're going to do one similar to 98 here. And let's see how we move forward on this thing here. Let me figure this out. Okay, so this one is, we're going to be using the same equation as in that last problem, number 96. The difference is what we're solving for. So let me go ahead and kind of just read the question and see what they're telling us here. So they tell us that rubidium has two isotopes. There's one called rubidium-85, and they tell us the mass of it. And they also tell us how much of it we find in nature. We find about 72% of rubidium is that isotope. They also tell us that there's this other isotope called rubidium-87, and that's the one they're asking us about. So they say that if the atomic mass of rubidium is 87.47, so this right here is telling me basically the average mass of rubidium. What is this mass of this second isotope? So what I'm going to go ahead and do is kind of, since there's so much info in this question floating around, let's go ahead and make a little chart to organize what they're telling us here. So again, there's two isotopes. We got rubidium-85. We got rubidium-87. Now, as far as all the info they give us, really, it all has to do with this rubidium-85. They're telling us the mass of it. They're also telling me how much we find in nature. 72% of all the rubidium is this first kind. Now, rubidium-87, they don't tell us anything about it, so that's kind of our unknown here. So we're going to go ahead and have to go ahead and figure out a little bit about this new isotope. So again, just like I showed you in class, the first thing that you're going to really want to do is, for this rubidium-87, before we can find its mass, I mean, I know that's what we're looking for, but before we can find it, we need to know the percent of it that's in nature. Otherwise, there will be too much unknown in that equation that we're using. So the way you can find the percent of it is if you've got only two things, you know that these amounts, the amounts need to add up to 100%. So what I'm going to do to find the amount of this other isotope is I'm going to take 100 and subtract the amount of rubidium-85. So if I go ahead and do that, it looks like the amount of rubidium-87 in the world is, I have to get out my calculator here and do it, is about 27.83%. So most of rubidium in the world is, again, this rubidium-85, but about 27% of it is rubidium-87. All right, we still don't know the mass. We're going to get to that. Now we do have one other bit of information, which is the average mass. All right, so I've done as much as I can without getting into that equation. So I guess we're going to have to face using that now. So let me go ahead and jot it down again. So it says that the mass of an atom is the mass of the first isotope times its abundance plus the mass of the second isotope times its abundance. Alright, so let's see what we got, what we can put in here. So again, this number here is our average. So that's what's going to go over here on the left-hand side. So over on the left-hand side, we're going to be putting in 85.47. Again, in the interest of space, I'm going to leave off the units, but you have all the space in the world on a piece of paper, so go ahead and write them out. AMU there. Now on the other side, we're going to be putting, on the other side of the equation here, the mass of the first isotope, which is this rubidium-85, so it weighs 84.91 times its abundance, which is 0.7217. Alright, plus the mass of the second isotope. Now its mass, I don't know. That's what I'm solving for, so I'll just write mass times its abundance. Now a second ago, using the fact that the amounts need to add up to 100%, we figured out that the amount of the second isotope in nature is going to be 27%, but again, you can't put in percents. We're going to have to move that decimal over 2 places and make it 0.2783. Alright, so I think we have everything in the right place. We got one unknown. If you're doing algebra, you can only have one unknown, and so I think we're going to be in good shape. Now we got to actually do the math. So again, when you have something that is over here, a lot of times what math teachers tell you to do is to try to work your way towards it. So working my way towards it, in other words, I'm going to deal with this stuff right here first, and that means I'm going to be multiplying these two numbers together. Let me go ahead and do it and see what we get, and then we'll have to do even more algebra to hopefully come up with that answer. So if I multiply that 84.91 times 0.7217, we get, again, I'll round to sig figs. Oops, I got to get to my pen here. About 61.28. 4 sig figs sounds about right. Alright, so we're just simplifying. That's all I'm doing. Just like good old algebra class. Now, next thing I got to do is I see this number here, this 61, and I've kind of gotten it a little bit simplified by doing this multiplication, but I need to get it away from mass because I'm trying to get mass by itself. So the way I'm going to do that now is I'll subtract 61.28, that's an 8 there, from both sides, and that'll make this cancel out over here. So this is going to go away, and so over on this side I'll have to go ahead and do the work. Let me go ahead and subtract it, and when I work it out, this right hand side now, it turns out to be, oops, back to the pen, 24.19 equals, and then again this canceled, so all I'm left with over here on the right hand side is gotta keep going back to that pen, mass times 0.2783. Okay, so we're pretty close now. One more step's going to get that mass by itself, and that last step is got to do the opposite. So if you see times, the way you get rid of something if there's a time sign is you divide. So we'll be going ahead and dividing both sides by 0.2783. And again, that'll make this cancel. And now we'll be left with, I'll have to go ahead and divide this on my calculator. And let me go ahead and divide what you see over there on the right hand side of the equal sign. And you're left with this. So the answer turns out to be 86 point, are we going to round? You bet we're going to round. 86.92. Are we going to write units? You bet we're going to write units. AMU. And that equals my mass. Okay. So when you try number, well, again, like I said, number 98, it's the same basic question. The only difference is they're actually trying to be a little nicer to you, and they're breaking it up into steps. So the first step is to find the average mass. Well, you're going to find that listed on your periodic table for silver. The second step, part B, they're asking you to figure out the amount of one of the isotopes. So you're going to use this fact that the numbers need to add up to 100 to do that. And then for the third part, part C there, you're going to have to go through all this algebra to come up with your answer. It should look just like mine, though, I bet. Just numbers are different, of course. Okay. All right, we're going to move on to the last problem here in just a second. All right. Okay, the last one I've been getting some questions about is like number 108 in Chapter 4 still. So I'm not going to I'm not going to go ahead and do 108 again. I'm not doing your homework. You should be doing your homework. But I'm going to do 107, which is pretty similar. And in class, actually, I think I did the very first line, so I'm going to be doing the second line down. So you notice there's this big old chart, and I'll go ahead and write it out. It says symbol, then it says Z, then it says A, and then it says protons, and then it says electrons, and then it says neutrons, and then it says charge. Alright, so second one down, they're telling me Z, and it says it's 25. A is 55. Electrons is 22. Alright, and they want me to fill in everything else here, so I'm supposed to fill in the symbol, the protons, the neutrons, and the charge. Alright, so I should tell you, I guess the first thing I would want to make sure is you know what Z and A stand for. So we did talk about this in class, but just to remind you, when I look at this, Z is the atomic number. Now, what does that mean? Well, atomic number equals always the number of protons. Alright, A, what does that mean? A stands for mass number. Again, if you just watch me go over 98 and 96, I talked about atomic mass. That is not the same thing as mass number. Sounds identical, but it is not. So we're talking about mass number in this question. That is the number of protons and the number of neutrons added together. Alright, so if I look at this first line here, they've told me Z. Z is the number of protons. So that means I can go ahead and fill in the proton line. It's 25. In other words, Z and protons are always identical. Okay. Alright, so it really doesn't matter where else we go next. I mean, I guess I'll just keep working my way over to the right, maybe. That sounds alright to me. So if I look over here, the next thing I could fill in is the number of neutrons. Well, if A is protons and neutrons, and you got protons, well, if I subtract these two, protons and neutrons, take away the protons, that's going to give me my number of neutrons. So in other words, 55 minus 30 makes, 55 minus 25, there we go, makes 30. Alright, we're almost done with this one. So the last one is to fill in the charge and the symbol. So again, maybe I'll do charge first, it really doesn't matter. But only thing that's going to give you charge are, well, the neutrons have no charge, right? But the protons and electrons do. So if you got extra protons, you got a positive charge, and that's what we have in this case. The question, they said there's 22 electrons. We figured out a second ago there's 25 protons, so that means we got 3 extra protons. That means we got a +3 charge. Alright, as far as symbol goes, the symbol, well, again, that's going to help you. What's going to help you with that is your periodic table. So again, when you look at your periodic table, the atomic number goes along with the symbol off the periodic table. So in other words, I am looking for element number 25, which is Mn, which is manganese. Alright, while we're here, I got nothing else to do. Let's do one more. Let's do the next one down. Alright, next one down, they tell me 3 things. Maybe to make this a little less confusing, maybe I'll do this one in a different color. Alright, so for the next one down, they tell me protons, they tell me electrons, and they tell me neutrons. And I got to fill in everything else here. Alright, so what are we going to fill in next? It really, again, doesn't really matter where you start. I mean, probably are some places that are easier than others, but considering I know protons and electrons, charge seems like it should be pretty good to start with. And I noticed that the number of protons and electrons are the same. So that means the charge of this thing, you ain't got extra pluses, you don't got extra minuses, you got the same amount. That means this thing's going to have a charge of 0. It's going to be neutral, in other words. Okay. Alright, let's maybe work our way to the left now. A, again, is the protons and neutrons added together. So let's find those. 15 protons and 16 neutrons. That means we got 15 and 16 protons and neutrons, 15 and 16. I guess that means that we got a mass number of 31. And again, two of these things are always going to be identical, the protons and the atomic number. So if you got 15 protons, you have to have an atomic number of 15. What element are you off the periodic table? Well, you're element number 15. So let's find 15 on our periodic table, and I believe that is phosphorus. Okay, so hopefully that'll help you with 108. Again, this is actually 107, but 108 is almost identical. If not, you can always call me or email me, and I can help you out some more. All right.